This week, first up is Sandy Bird from Sonrai discussing how to protect our cloud infrastructure. Then in the security news, help, I'm Fortibleeding. Cisco SD-WAN needs help. The secret life of probe requests. Help, I'm also Squidbleeding. Cross-site scripting to remote code execution and why CVSS isn't the full picture. Your TV is spying on you. Foundational security practices. Cybersecurity costs money. Happy it's too late to update your Microsoft cat key day. You don't have security flaws if no one can report them. Rickrolling FIFA, domain takeovers, end of life, out of luck, and the key to encryption. All that and more on this episode of Paul's Security Weekly. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Coming to you from the Hacker Syndicate Studios, this is Paul's Security Weekly. It's episode number 932, being recorded on Wednesday, June 25th, 2026. I'm Paul Sidorian, joined by Mr. Larry Pesce. Larry, welcome.
Thanks for having me. Yeah, it's been an interesting week so far.
I know. This is my first day back from vacation, so you can imagine what busyness that brings.
Just got back from college orientation. So, yeah.
Busy summer. Mr. Lee Neely is here with us. Lee, welcome. Sorry, Lee. I saw that you were muted, and then I called on you because you were just next in the order that I had.
Yeah, it's totally cool. I muted because something started making noise all by itself in the background, and I finally got it to shut up.
What's Shelly doing?
Something.
No, actually, it's not her fault at all. It's me. I'm the one who's clicking on stuff.
Mr. Josh Morpett is here with us. Josh, welcome.
Thank you, Lee. And that's when you hear your name. That's when you click on the mute button. Just letting you know, okay, man.
He was distracted,
I always thought it was when I heard your name.
Details.
And live from Tour Camp, Mr. Dave Johnson is here with us.
Hey, everybody. This is not the worst on-site reporting I've ever done. Definitely having a great time already.
Looks nice. Mr. Jeff Mann is here with us. Jeff, welcome.
It's not tour camp, but now I'm getting anxious to head up to upstate New York for Gray Fox Bluegrass Festival in a month.
Nice. Awesome. Quick announcement before we get into it. Let's be real. Your scanners are dumping thousands of vulnerabilities. Half of them are noise, and you still don't know what's actually exploitable in your environment. Patching everything isn't possible, and chasing CVSS isn't working. Got a great example of that. Probably a couple, actually. At the Vulnerability Management Virtual Cybersecurity Summit, you can learn how to prioritize based on exploitability, reduce false positives, and actually fix what matters. Security Weekly listeners can register for free at securityweekly.com/vuln management using the promo code CSS26-SW. This segment is sponsored by Sonrai Security. We have with us today Sandy Bird, the CTO and co-founder. Sandy, welcome to the show.
Hey, thanks for having me.
It's good to have you. Sandy, start off by telling us how you got your start in information security.
That was 20 plus years ago. I was one of the co-founders of a company.
So you're a noob.
I'm definitely a noob. Only 25 years, whatever. Cool. Yeah, I was one of the founders of a company called Q1 Labs many, many years ago. And that created a SIM product, if you remember those things, before AI SOC took. Yeah, exactly. And, years went by, we ended up selling that to IBM. And when I moved over to IBM after the acquisition, I was the CTO of their security division for 5 years, actually, which is, most people say, IBM acquisition, you're going to leave. But I actually stayed for a while. Nice. It was really neat. We had all the security researchers as part of our group, and I learned tons of stuff about quantum encryption and stuff that even my head still doesn't quite understand. And so that was all kind of fun. And then at some point in time, I said, look, I got to get out of a big company that has 300,000 employees and get back to, some people on a whiteboard. And so we founded Sonrai Security. And this is in like the 2018 era. And we looked at these cloud platforms, the hyperscalers, AWS, Azure, GCP. And I looked at all the stuff I'd done in the SIM world for years and said, for years I'd been selling this stuff saying it understands these clouds fine. And then I actually went and looked at the clouds and said, we didn't have a clue what we were doing. We were looking at these clouds.
Right.
And so we unwound that, discovered there were some really serious identity, I'm going to call them problems or opportunities in the clouds to solve. And so we really, really focused on that. And so I spent, years building least privilege inside of these hyperscalers for people. And a couple of years ago, I actually sort of gave up on that vision. I discovered that we're generating like 10,000 tickets, 100,000 tickets for a team and saying, go fix all the stuff that you've done. Nobody's going to fix 100,000 tickets. That doesn't make any sense. And so we found a way to do least privilege without the developers having to do any work. So that was much better. And they have a tendency to like that better in their life. And it gets you to least privilege and security without having to do the work. So that's my...
So it's really more privilege management and control, not so much like cloud security posture management, which is like auditing your configs, right?
Correct. Exactly. Like when we started, that was all one thing. Like nobody really differentiated any of it. And then over time you had kind of the CSPM world, the CIEM world, which was the identity side, CWPP, which was the workload protection and the vulnerability stuff. And it all became CNAP at one point in time. Still is, I think, still use that category. And then so we were quite narrow compared to say Wiz or something that does everything for everybody. And so that was where that kind of came from. But we've really focused over the last couple of years to just solving this kind of identity problem that happened within the cloud. So
yeah, because it's so much work, right? I mean, this is my day job, right? We're very, very careful about privileges, right? And when I joined the company, I was in marketing. And so like by default, like that role gets like no privileges, right? But they're like, you're going to do security research too. And so I have to request every, bit of privilege that I need. And it's very, very daunting. And that kind of, like it culminates. So funny story, I vibe coded an app for myself. And then all of a sudden, everyone in the company wanted to also use it. And I was like, well, I never intended for that to happen. And they're like, we should deploy it to insert cloud provider here. I'm like, great, never used that particular, infrastructure or hyperscaler before. So here I go with AI. I'm like, can you just go deploy my app, like link it to GitLab, make it, a pipeline? And I'm like, I don't know how that works. I'm just relying on the fact that we've got privileges and people looking over that, right? And that's just one small use case, but there's so many details there. Sandy, how do you tackle that problem, and how do you allow developers like myself, especially for like a small internal app, to go within the guardrails and not create a huge exposure for the organization, right? That's the goal.
Yeah. And again, I think this was kind of my epiphany 2 years ago after doing this. And we had, like I say, all these customers were saying to the developers, you have to go fix the stuff that they had already put in, right? That time they weren't vibe coding the app, but they built the app, they deployed the app, and it was there. And now we had to go clean it up. And so we changed the model. Instead, what we did, we used all this analytics to go back in history and see everything that the app had done previously. And instead of telling the developers, go fix the identity on the app, we used all the cloud providers, all the hyperscalers have these global security policies that you can put in place. In AWS, they're SCPs, service control policies, or RCPs, resource control policies. And so what we did, we inverted the logic to basically restrict the privilege permissions at the global level. So everybody was denied. No one could create a VPC, no one could create an access key, no one could do that. But we used the history to then make exceptions in those global policies for the things that needed them. And so all of a sudden, everything that had ever created an access key before, whatever, was still able to do it, but everybody else that was privileged to do it that didn't. And so you had this kind of,
so it's based on activity.
Yeah, exactly. So it almost creates a whitelist of the things that need privilege, and basically default denies everything that doesn't need privilege. And so you end up in this least privileged state with no work. You don't have to do anything.
It reminds me of when I used to set up firewalls and just put allow rules in and then monitor and go, oh, I should definitely be blocking that.
You got it.
I should allow that, and then culminate in okay, now that rule is not allow, it's deny, and just hope that I got it right and I monitored long enough. Right, this was before AI tooling and all that stuff, and usually you got it wrong. Right, usually there was an exception, but if tooling we have today can monitor that activity and create it. That's pretty cool. You're probably sick of the word agent, but here's the problem. Your dev team is handing every new agent in your cloud way more permissions than it needs. And when one goes rogue, you've got 4 minutes before your data's gone. You need a default deny button that doesn't break every workload. That's Sonrai's Cloud Permission Firewall. native IAM controls, not newfangled AI nonsense. Default deny on every agent and human identity automatically. Learn more at securityweekly.com/Sonrai. That's SONRAI.
And I think the exceptions are interesting in that this is where my security background comes in. If something has never pick your poison, created a pre-signed URL before, used a certificate to sign something, whatever it is. No, it's never done that before. That is maybe intentional. You're building a brand new workload and you need it to do that. Okay, well, It's okay to put a little bit of friction in front of that and say somebody has to press a button in Slack to say approve it or something, right? You can do that and it's acceptable. But it's also a really high fidelity signal to the SOC to say, this workload just woke up after 2 years. It's never been used and it just did this.
Yeah.
Do you want to wake that up or not? You probably don't actually. In many cases, you want to investigate why it did it. And so that's the way that we kind of do it. We put all these hooks into the cloud to know when these things that need the exceptions are there. We pass it to the team. They can approve it and it becomes normal, or they can say, this is really suspicious. We need to hand this to the SOC to do some work on.
Right. It's that never before seen or haven't seen it in a really long time events, right?
Yeah,
that are
exactly.
Usually the ones that you can do some investigating with, or want to do investigating with.
Yeah. Like there's that. Go ahead.
I was just going to comment. I just read that you named your company in Gaelic.
We did name the company in Gaelic. It's by the way, super hard to find a domain name that has anything to do with identity or data. They're all taken.
They're all taken. Yeah,
they are all taken. And we stumbled upon this word Sonrai, which in Irish Gaelic, specifically Irish Gaelic, means data. So it's kind of neat.
And it's got AI in it?
And it has AI in it, yes.
That's
exactly.
Oh my God. That's awesome, dude. Congrats. That's really, really cool.
Now, but it's running out.
Before.
What else in Gaelic has got AI in it? And I can name my startup.
In Gaelic?
And what other language
has AI in it?
AI.
Little does he know that Larry just bought up all the Gaelic domain names.
Well, since we were going off topic slightly, I'll just continue on. You're in Canada. What part?
So I am in New Brunswick, Canada, which is on the very east
home
coast,
of the bowling ball.
There you go. Exactly.
Have you ever been to any of the Canadian security conferences? Are there any that you recommend?
Yeah, TorSec is a decent one. CCTX, Sector. Sorry, yes. Maybe I'm dyslexic. I don't know. Whatever.
TorCamp, Sector. We got it.
Yeah, and CCTX. I was actually just. I think it was 2 weeks ago. We did the Toronto AWS. We're very cloud, so broad scale security conferences aren't really always our thing. We prefer to have the cloud security conferences. They work better for us. And I was at the Toronto AWS Summit last week, or 2 weeks ago, maybe. It was pretty good, actually. It was decent. So,
okay. Sandy, one of the things that I think we're all concerned about, but especially engineers working in these cloud environments, and that's management of secrets. And there's obviously the wrong way. There's the wrong way, the right way, and like every way in between. If you've done that, I think that probably makes sense to you. How does your product give us insights into that? Because that seems to be maybe one of the number one exposures, right? Is how these apps in the cloud are dealing with secrets.
And again, it's different in each cloud, by the way, because the story is different in all three of them for sure. And then you have, the fact that most of the cloud identities themselves should have done away with secrets and are using short-lived credentials anyway if you're using them properly. So you shouldn't have to use secrets, but you always have to do it. So first of all, for the AWS secret side of this, if you were cutting real like AWS access keys, that's one of those privileged permissions, right? So we're just protecting the creation of them to begin with, because you probably shouldn't be doing it. You should be using short-lived credentials. Then we're also protecting, editing of the secret access policies. So, it's one thing for the secret to be accessible to this workload. Too many people put it in where it's accessible to the whole account. So once the attacker's in, they can grab the secret versus the workload doing it. So we're protecting all of that on that side, which is also good. Again, and we can flip clouds here. If you go to GCP as an example, I actually think we're probably one of the only companies. Datadog, by the way, is the other exception. Datadog and us are probably the only two that do access to their cloud via third party without using secrets. Most of the vendors create a service account, cut a key on it, and use it, which is horrendous, by the way. Because you can do it using short-lived trust. So again, we're protecting the secrets to make sure the secrets themselves are protected. We're actually making sure that, you're not cutting long-lived access keys and things of that nature for that. But what's most important, I was going to say before we just move on.
A 10-year key is a problem? Come on.
I like the 2099 ones. Those are the good ones. The other thing that's super neat about what we do is those keys in those clouds, whether it's however they do it, whether it's a long-lived secret or it's even a short-term one, they often have privileged permissions. And so what we do is make sure that if that key has never, ever used any of those privileged permissions before, it's going to be blocked before it does, and somebody's going to have to approve it. And the idea for this actually came from watching. You got to remember, we have history, right? So we were building those KIM products before that were generating these least privilege policies, which nobody ever applied, right? You know what I mean? There'd be like 10,000, they wouldn't do it. And they would get red teamed. And so the red team would obviously pop the Git runner. Then they would use the Git runner to use that to create a IAM user, put an access key on it, and then come back into the account that way. It was a super common And they would go back and say, well, why didn't you catch this, Sonrai? It's like, we did. We gave you a least privilege policy a year ago that you never applied to Git runner that said it shouldn't create access keys. And so that was kind of the idea behind this thing, was like, but wait, if it's never done it before, why did we let it do it in the first place? And so by basically putting these global policies in that says no one cuts access keys unless we already have them in the approved list, removes all of that risk. So when the red team goes against this, they just bang up against a wall. And there's been some great stuff in the last little while in AWS, like these intentionally vulnerable AWS accounts like CloudGoat. There's Datadog just did a really new one with, I think it's Island something. And if you put these controls in, it completely destroys attacking those. You can't get through them because something would have to approve you going through all the paths. So works quite well.
It's great. Yeah, a lot of security is about exceptions, and we tend to make lots of exceptions, but never audit our exceptions. And it sounds like you're just making it so that the exceptions are never valid, right?
Yeah. There's this kind of neat thing on that exception thing too, which we've seen a difference in the last 6 months, maybe. Our customers would always put like their golden pipelines in the exception list and say, like, just let them do, if it's the build role, putting in whatever, just let it do whatever it wants. We don't ever want that to be interrupted. And kind of in the we'll call it the pre-AI era, especially with these kind of interesting supply chain attacks now, or bad NPM repo, whatever it is, you end up with these problems. They're now actually starting to gate those. Actually, they're saying, look, that thing shouldn't have, just carte blanche permissions all the time. When we're doing a deploy, it should have it. It should have for the privilege that it needs, but no more. And that's been a real change in the last 6 months. Before that, almost everybody was just deploying them completely wide open. So.
Does that go for like general access too? Because the cloud basically has its own firewall, right? And so when you deploy an app, you state oftentimes programmatically, like infrastructure as code, like what should this be exposed to? And you have lots of options as to how that can be configured. I'm assuming Sonrai also kind of helps you with the keys aside, like that general, like this shouldn't be exposed to the public internet. It should only be exposed to this set of VPN, and it's not even VPN, right? It's some cloud-based thing or Cloudflare or whatever.
There's 2 parts for us. So we're definitely not the network firewall, right? That's not what we are. And so we're not necessarily looking at every one of those controls and stuff and saying, what did you do? You built the app, you do what you need to do with it. But in almost all of the clouds, in order to change those things, so, as your example, change a security group rule in AWS, you want to change those rules, that becomes the privileged permission. So generally speaking, there's only 1 or 2 things in the account that should ever be able to do that. And so those are blocked for everything else just by default by us. So you would never be able to expose it to the public. But then the cloud providers have created all these crazy bypasses for this stuff. So like SageMaker, which is this AWS service, allows you to, train new LLMs and all kinds of cool stuff in it that you might want to do for analytics. One of its permissions, like the API call you can make, creates a pre-signed URL and exposes the SageMaker notebook directly on the internet, bypassing all of those rules you just talked about. However, it's very rare that anyone ever does that because they're using it internally and all these things. And so that becomes one of those privileged permissions. It's like if the very first time somebody goes to use a pre-signed URL at a SageMaker, somebody should say, yeah, I intentionally wanted to make that public. That's something I wanted to do. And so we just put those blocks in. But, think about something like Expensify where, they're grabbing all these receipts all the time, right? Those end up being public objects in an S3 bucket. It's how they do it. They all have, weird, whatever URLs to them, that are supposed to be super secret. You can we can claim if they are or they're not, doesn't matter. That's what they're supposed to be. And those are all public copy. If you put our app on top of that, we would detect that that's normal behavior for that application. So that's okay.
Right.
But if you logged in and all of a sudden started to, create these pre-signed URLs, then no, you got to go through another hoop to get there. So,
right.
So you have multiple applications behaviors mapped, so
Right
that you
down
can
to-
say this is normal, this is somebody doing something stupid.
yeah,
Effectively.
we have this amazing compression of every identity by every permission, by every resource. Was it allowed? Was it disallowed? When was the last time it happened? And we have this thing that we keep. So we have this kind of summary, and we use that to basically build all of these models out to know that, Joshua absolutely changed security groups in EC2, and Paul absolutely
Damn,
created
they
pre-signed
found me.
URLs. Yeah, they found you.
Yeah.
But you know what? Jeff never does any work. He just uses read-only access and list stuff, but he doesn't actually do anything. So we have that map there all the
Jeff.
time.
Obviously, he's a long-time listener.
There you go.
Jeff, there's a lot of noise coming from your mic for some reason. I don't know why. It just changed.
I just moved it. I might have jostled the wire. Sorry.
Oh, okay.
Are we good now?
I think we're good now. Yeah.
Okay.
Yes.
So, Sandy, well, one thing that's interesting, I think it's especially true when you're first developing and deploying a new cloud application. Because the first time you do it, at least when I did it several years ago, my permissions were very relaxed because I needed it to work, right?
Yeah.
And we've evolved in that, but there's still a, you're new to GCP, and in order to get this working, I had to relax the permissions. Can you identify a new app that has more relaxed permissions because it doesn't have that history, but engineering was well, we got to create this and make it work, and we'll always go back and secure it later, which, as we all know, never happens.
Never happens.
Can you help identify those scenarios? Because I feel like those happen.
If we are in place, so if you've deployed Sonrai, you've got 100 apps already running, and you're going to deploy the 101st app. Because you're doing that, in each of these clouds, you're going to have, you say GCP, you're going to have a test project in GCP that you're building it in, or your sandbox, then you're going to move it to some QA environment and then production. What we do is that Sonrai is a deny first scenario. So when you deploy that in that sandbox account, almost everything privileged you do is denied by default. And so it's kind of annoying in that first time. You're saying, oh, well, the very first time you create the network, you're going to have to get an approval. And so we do two things to alleviate that. One is most of our customers in that zone of development sandbox just allow self-approval of the developers themselves. So the person hitting the rule is allowed to self-approve it. The second thing we do is we group up permissions that are common together. So if you create a network, you're probably going to create subnets. You're probably going to create an internet gateway. You're going to put some security group rules in. You're going to put some firewall rules in. So we kind of group those all up together, and you can choose to time box them. So you give it to the thing for an hour while it deploys, or you give it to it forever, depending on the way the application works. And so during that first deploy, you got to hit approve a couple times in Slack or Teams or wherever it comes, but it's instant. You just run the app, you run the Terraform, it hits the wall. We detect that instantly. We send you a message that says you need to approve this. You hit approve, you run it again, you do it 3 times, you're done. The thing's deployed. What's nice about that is now you have the exact list you need when you promote it to staging and when you promote it to production. And so,
Right.
But you take the friction out of it because the developer fixes it themselves. They don't have to go ask the person that does IAM permissions to go fix this stuff for them. Or in your case, they just don't give it star. They actually may give it star, but it doesn't actually have star because we put the global policies in to block that stuff.
Yeah.
Yeah.
So you have global policies help people not deploy an app that has too many permissions, which
Correct.
is all too common.
Yeah. Well, and things just never get those permissions in the first place. If they've, you can deploy it with star, but if it never uses Bedrock, then it just never has those sensitive Bedrock permissions in the first place because they're denied globally. So, yeah.
So if I can interject, on the show the last month or two, we've been having sort of this ongoing discussion about the fundamentals of security, and we've had some lively discussion and debate about what that means. I'm curious as to from a cloud perspective and a cloud security perspective, all the things that we've been talking about, I'm hearing glimpses of this. Sounds like it falls into the category of what some might consider a security fundamental. So what's your take on the fundamentals of security, especially as it applies to cloud security, and how are you tackling that? How are you making your system, to use an archaic term, idiot proof?
Yeah. So first of all, identity is kind of having a rebirth, I guess, of importance lately. So definitely it's always been a fundamental, and certainly one of the most important things. In this exact moment in time, vulnerabilities are having a moment, of course, but identity is still really important. So it is absolutely fundamental. The idiot-proof part of this product was, and this is the challenge we gave ourselves 2 years ago when we were trying to figure out how to fix people, or fix not having 1,000 tickets to go fix. We said the users of the cloud must continue exactly as they did before. They do not need to change their behavior. And so by actually building this kind of, you want to call it default deny with whitelists, but using the history and analytics to figure out what is normal, so that gets applied by default, the users don't have to do anything. And on day one, when you deploy this and you all of a sudden go from everything was too wide and too open, and we see that the statistics are insane. Like 92% of the identities in any cloud, the humans, the workloads, the AI agents, are overprivileged in every cloud. And so when you turn this on,
is it not the cloud equivalent of plug and play? I mean, we
could say that. Yeah, it's in the reality is there's one step before plug and play, and that you've got to build, these rules, and you've got to learn, and then you plug that in. And when you plug it into these global policies, you're now in that state. But it doesn't impact anybody that's there, so it doesn't break the developers, and things like that. And so they just keep doing what they were doing. And the worst case example is they have to hit approve in Slack. It's really easy.
Cool. So I remember back when we were working with cloud services, they were always introducing new functions, new features. And we always had the conversation about, is it secure enough?
Yeah.
Blah, ... So I'm thinking you've got to be constantly evolving to accommodate these. I mean, what's that?
There's
are you just the snake eating its tail? How do you do that?
We've got years in doing this. So every week there are new permissions in all these clouds. And so we go through those every week to make sure, get lots of analytics that do it and some AI that say, is this privileged or not? And then the cloud providers change stuff. So stuff that wasn't privileged yesterday becomes privileged today because they add functionality to the API call. So you have to keep track of all that. And so from our customers, what happens is as soon as one of those things becomes privileged, we actually bootstrap that into their permissions and they're automatically protected for it. They don't have to keep track of it. And the great thing about default deny is a brand new service shows up. It's never been used before, so it has no history. The very first person that hits the button, somebody's got to hit approve. And so a lot of our customers use this, like in the early days of Bedrock, they would want to try it in one or two accounts, but they wanted to globally deny Bedrock everywhere else. And so that's what they would say.
What is Bedrock?
Sorry. In AWS world, Bedrock is where you go build all of your AI agents. So in GCP, you do it in Vertex, and Azure's got some other service, but every one of them has their set of AI services. Yeah.
So I'm thinking, I'm flashing back to remember when we first messed with S3 buckets, nobody realized they were world read.
Yeah.
You had to lock them down, and that lovely global namespace. Not here to bash on them. I'm thinking it sounds like you're in a pretty good position to prevent the next S3 bucket adventure.
Yes. There's been several examples of this as these new AI services rolled out, like Bedrock, where there were vulnerabilities in them by default. There were, again, there's lots of research on our website. People can go look at it if they want, but Bedrock had some pretty big gaping holes there for a while, and lots of container escapes, and you could sneak your net data through DNS and all kinds of interesting things with it. So.
Yeah, I mean, I love it because, any organization has so many developers that are deploying stuff into the cloud infrastructure, and you need something that is preventing them from shooting themselves in the foot. Yeah. Even the most well-intentioned engineers, because of the complexity and the ever-changing landscape in this cloud infrastructure, it's super easy to shoot yourself in the foot. So I feel like I'm like you, as you're describing it, saying like, I need this just because I want that stopgap, right? I want some kind of backstop protection, because it's too easy to make a mistake and create an exposure for your organization.
It is. There's a kind of neat other thing that we do, which I love, and it's one of those things that our customers love. We also just detect stuff that gets left behind. So there's another cool stat. If you've been in the cloud for 5 years, so if you've been there for 5 years, you've been building an AWS, Azure, GCP, 50%, half of all of the identities sitting there are unused in that cloud.
I believe that.
Yeah.
100%.
And and again, back to my history, when we were trying to do this perfect, we would generate tickets and say, you need to go remove this stuff. And none of the developers would delete it, because they'd be like, but if I delete it, I don't know how to put it back.
It's gone.
Right. And it's gone. I don't know
we
what
all
to
like
do.
to hoard. We all like to hoard stuff.
Hold on to our stuff.
Like, yeah.
So we did this kind of neat thing when we built this model and said, well, if anything is older than X, you pick X, 90 days, 180 days, 366 days. I don't care. You pick the time. If it's older than that, we put it in quarantine. And it's super simple. In the global policy, we basically just say default deny, the thing doesn't work anymore.
Right.
But then we also put these hooks in to say, if it ever wakes up and does something, tell the team about it and ask them if they want to wake it up. And so, you'll have this thing that sits there asleep for, 368 days, wakes up and lists buckets or tries to access a certificate or something. And the team gets a note saying, this thing hasn't been used in 2 years. And it just woke up today and did this. Do you want to wake it up? Yes or no? And, clearly you don't most times. But if you do, you say, yes, it's the yearly report. We need it to wake up, and it goes and runs.
Yeah.
And so what's so neat about it is you have customers with like 50 or 100,000 of these things in quarantine. And the number that wake up in any given week is like 5. It's the risk reduction is massive. And it's the simplest feature. It's so simple, but yet it's one of the most powerful things. And it's, anyway, the statistics on it are super neat.
I feel like there's a lot of like sci-fi movie references to like things waking up after like thousands of years or something like that, right?
It almost feels like, given sort of that exercise, like, hey, we're putting it in quarantine because we don't want to lose it, that you're getting that message that it wakes up. Like, to me, my first reaction was, like, of course I want to. It woke up. I want to allow it to do something. Of course, in reality, it's a very good possibility that something bad has happened.
Yeah, exactly.
So, I think that's a little bit of a human nature thing that probably need to get past that particular set of rules.
Well, I'm wondering if, okay, let's say we got this thing that wakes up every 363 days. You could if you model that and such that if it wakes up after 200 days, you're saying Whiskey Tango Foxtrot.
Yeah, it's too early. There's something really wrong. Yeah.
Yeah.
That compression model is super neat that we use. You actually could gather a lot. We don't do that, by the way. We just do it. We kill the thing after whatever days, and we wake it up when it wakes up. But you could absolutely do some pretty neat analytics on it to say, well, yeah, this one's early. Why is it doing it now? So
right.
It's a good idea, Lee. We're going to put that in. We'll
good job, Lee.
Attribute it to you.
The Lee Neely
really
feature.
Cool stuff. Sandy, I got to tell you, this is really you explained it very well. This makes sense. This is needed. I don't think anybody's going to argue it's needed. Where permissions and identities are just desperately bad right now. Okay. Like, it's bad.
Yeah.
So the ability to do one click, full cloud done, have a nice day, thank you for playing, bye, is
But Jeff, did you have something? Go ahead.
Well, I'm noodling. I mean, a lot of my clients are in the cloud, but they're very much relying on third parties to ostensibly do a lot of the security fundamentals for them. I'm just trying to figure out, how do you encourage companies to do this kind of thing when they think, just because they're in AWS or GCP or Azure, that so much is being done for them automatically? Mm-hmm. It's got to be built into your pitch somewhere along.
We do. Again, we always do these kind of interesting assessments where, people you can actually just go to our website, sign up for a free trial. What's nice is the main dashboard gives you the view of how bad things are, but it only has like 5 statistics on it. It's not super complicated. It's like, here's 5 bad things. You get this many zombies, this many overprivileged identities, this many services you don't use, this many third parties. And so you kind of see that very quickly. And then from there, it kind of sells itself. It's like, oh, you want to fix it? There's a button. Press the button, fix it. But a lot of people will do that. They'll just plug it in for a thing and say, oh, this is clearly
I thought I was secure. Follow-up interview with your package. I want to see an online live demo of we'll pick a victim.
That would be we should
That
definitely
would be fun.
Yeah.
Awesome.
I'm upselling,
Sandy,
maybe. I'm sorry.
Sandy, anything else you want to share with our audience?
Look, again, if anybody's interested in our product, we would love to interact with you. You can reach us on our website, LinkedIn, and all of those things, sonraisecurity.com. You can sign up for a free trial. We do all kinds of risk assessments and those things too. So again, we'd love to connect with anyone who's interested. So.
Awesome. Sandy, thanks so much for joining the show today.
Thank you.
With that, take a short break. Come back with the security news. Stay tuned. Zero Trust is clearly the future as threats get faster, quieter, and harder to detect. But implementing it shouldn't disrupt the business. ThreatLocker enforces default deny at execution in a way that remains enterprise-ready, scalable, and operationally clean. Unknown software is stopped cold, trusted apps stay contained, and drift is locked down across the environment. It's Zero Trust that works in real enterprises and prepares you for the threats ahead. See why CISOs are adopting it at securityweekly.com/ThreatLocker. And we are back with the security news. We don't have Josh Marpet yet. I think he's still on break, but we'll bring him back momentarily.
That's why we assign all the work to him.
That's right. That's what happens when you don't show up to a meeting. You get all the work.
Mm-hmm.
And
all the action items go to the missing person because they don't object.
This is true. Where do we want to start tonight? Is there anything that you guys really caught your eye before we kind of warm up into
what caught my eye is you're not Paul. I use Arch, by the way. Did you happen to watch last week's or listen to last week's segment?
I listened to some of last week.
Did you?
I was not here.
We had a special.
Listened all the way to the end just for you.
Yeah, we had just for Paul segments. What the hell?
I do listen when I just haven't completed the episode yet. So
okay.
So I'll go back and listen.
Spoiler alert.
Yeah.
How many of us talked about Fortibleed? I mean,
did we talk about it last week?
No, we did not.
So I think that's where we start.
Yeah. So we could literally devote the rest of the time most likely to this, but I will try and summarize the most important things. So here, bear with me for a moment, and then we'll discuss. So, threat actor left all their tools and data exposed to the internet. Someone found it and grabbed the tool set, the tools, and the data that they were collecting via this campaign. There are many TTPs in here, but essentially the threat actors were scanning, identifying, exploiting, and capturing data, especially credentials, primarily through Fortinet firewalls, although there was some evidence of Sophos and other technologies, Microsoft SQL Server and other things in that campaign as well. But it was interesting, kind of mirrored a tool set that I did a proof of concept on that scans the internet, or a network segment, tries to figure out what the device is, tries to log in, based on what it fingerprinted. And the attackers had I thought, a very good design to their malicious activities in the way that it was implemented. And we were able to map all of that because they leaked all of their tooling, and a bunch of folks in different companies analyzed that data. One of the interesting things was they were able to collect SHA-256 hashes. They were able to rent, I think it was 40-something GPU cluster to crack those hashes, which was kind of interesting. Inside their tradecraft, one of the things that you could have easily glossed over is they had technology to detect honeypots. So in their system of scanning, if you were able to log in successfully like 3 times in a row, they were like, well, that's probably a honeypot, because most production systems, we probably wouldn't be able to guess the first 3 passwords and have them be accepted. I think that was the extent of their checking for that. They were also filtering a lot of the device fingerprints and credentials. So they went through multiple passes of going, is that a Fortinet device? Is it really a Fortinet device? And then if so, go do the next stage. Once they compromised a Fortinet device, they were primarily living off the land. This is an area I spent some time investigating, because I'm like, if they did stuff or deployed malware to a Fortinet device, I want to be able to go detect it. And really what I saw was them just running I forget the exact command, but it's the command that allows you on a Fortinet device to sniff packets. And so they didn't need extra malware for that. They used built-in Fortinet functionality to sniff traffic. And they weren't just sniffing for more Fortinet logins, they were sniffing for all kinds of credentials and building out a database. This is where it gets like I had to spend a lot of time to really fully understand this. So this is important. So I talked about SHA-256 hashes.
Mm-hmm.
If you're running FortiOS versions prior to 7.2.11, 7.4.8, and 7.6.1, so before those versions, you are storing passwords that are either SHA-256 hashed or some other hashing algorithm, both of which, by the way, are can succumb to being cracked, especially the SHA-256, as evidenced by the GPU cluster. So versions prior to the ones that I listed, you're basically vulnerable, right, to this hash crack. Vulnerable, but it's more of like a misconfiguration. You're storing the passwords in a format that anyone with a credit card can go to a hosting provider and with 40 GPUs and crack it. So if you're running the newer versions of Fortinet, I won't keep saying the version numbers, but after that version number or later, Fortinet switched it so that the passwords are being hashed with PBKDF2, which is just for the sake of simplicity, much better hashing algorithm, more resilient to password cracking. But there's a caveat there. So you run the older version, you're hashing your password SHA-256. Once you apply the update that gets you the PBKDF2 hashing, your password, like the value stays the same. So you still log in with the same credential, but in the surface, so if you do a show running config, the equivalent on FortiOS, it shows the PBKDF2 hash. And so your password has been basically rehashed with a new hashing value. However, it stores the SHA-256 hash in the config somewhere. And that storage post-upgrade is only in the show full, or a configuration backup. So you have to do like a full configuration backup. Like you have to go either run the commands, go in the interface, go, I want a full configuration backup. And that's where your SHA-256 hashes live. And it does that because I was questioning this. I'm like, why does it do that? Well, let's say you upgrade from 7.2.10 to 7.2.11. Now you get the new password hashing algorithm, but something else broke and I need to revert to 7.2.10. Well, if I don't store that old hash, I can't revert. My password would be invalid. So it does that so that you can revert and it still stores the previous hash so administrators don't get locked out. I understand the problem. I'm not saying I agree with how Fortinet necessarily went through the process of trying to fix that. So that presents a problem in that once you've done the upgrade from version that stored passwords insecurely to version the passwords are stored securely, you've now got new password hashes, old ones still stored there. As an admin, I have to log in order to wipe out that old password hash. So it's only on first successful login that it wipes out that older SHA-256 hash. And it does that not just for one admin, right, but for all of the admin accounts that you have on there. So that's the kind of weird thing. Like if you're vulnerability scanning and you're just doing it based on version, there's this like weird nuance where you could still be storing an old password hash.
Right. So
that's basically Fortibleed in a nutshell.
Like change all your passwords, because that would also force it to be written with the new hash, right?
Yeah, but in this case, Lee, you don't have to actually change you should, to your point, Lee, change your password, right, because you can
change it to the same thing again and get there.
Right, but you should change it because it could be that your password was leaked, right? There's that. So definitely change all your passwords, enable multi-factor authentication. Obviously you can still log in through the web interface, but for SSH, key-based authentication, obviously way better than password-based authentication. That certainly you can do that on Fortinet firewalls, would be a good thing to do. But if your admin web interface is exposed, the SSH key doesn't mitigate that thing. So it's best to change all your passwords, rebuild all your devices. If there is no software update available for your Fortinet device because it's end of life, you should throw it in the trash and go buy a new one.
Yeah.
So there's that.
So there was a couple things about this that caught my eye. One was the scope. They identified, 74,000 Fortinet devices in 21,000 domains in 194 countries. This is not a small attack.
Yeah, essentially they used mass scan to scan the entire internet for Fortinet.
Which
and did it in a way, like it's kind of frightening actually. They did it in like the same way that I built my proof of concept. That would do mass scanning. Mine was of your internal network, find all the live IP addresses, then go run another tool, identify what kind of device it is, enumerate all of the protocols available on that device, do some more investigative work that based on the protocol, what it responded, is it a Fortinet device or is it a Cisco device? What is it? Then based on that, what credentials do I have that I want to send to it, right? I mean, that's the like fundamentals for doing this type of work. I was doing it so defenders could have a tool that did this for them, but the attackers basically built the same tool that I kind of envisioned in my proof of concept, it's kind of frightening, right? I was building it with my vision of defenders running this tool to enumerate all the issues in their environment. Like, do I have Fortinet devices with a default and or weak credential? Well, I need a tool to go help me with that because vuln scanners traditionally, as Jeff can tell you, right, haven't been great at that. But the attackers built like the same, like the workflow is identical to the proof of concept I built for my engineering team. I'm not saying we didn't necessarily implement my crappy proof of concept, but it was just like if we were to do this, like here's something like stimulate your brains, right? Wasn't production ready or anything, but it was proof of concept. But the workflow matched almost identical to what the attackers built. That's what freaked me out about this one. I'm like, that's kind of freaky.
So did you have a chance to look at the Hudson Rock lookup tool?
Yeah, there were many lookup tools, and I all it's doing, I believe, is just matching your IP address to what was in the data leak. Yeah,
I mean, there's the domains, and it's got the compromised credentials, and both the IP URL to the login or whatever the heck, as well as the account that was compromised. Not necessarily all the details, like obscured at oracle.com. But I just thought it was interesting at the time. I only saw. It's been a couple of days. The one lookup tool popped out, and I thought, okay, that's kind of neat because it's like, have I been pwned? If you have somewhere to look, right?
Right.
But I was wondering how good it was because you've dug a lot deeper in this than I have.
Yeah, basically, I had to for my day job, right? Because we want to give people coverage for this,
of course.
But I can't find the exact command the attackers were running to sniff packets. There is a way to pull that from your logs, by the way. There's a lot of great resources out there that if you turn on like auditing on your Fortinet firewalls, which I don't believe is on by default, it'll actually audit the commands that were run and write those to a log. So you can tell, have an indicator in a log file that someone issued the... I wish I could find the command. I didn't put it in my show notes. But you can tell when people run the command to sniff, use your Fortinet firewall as a packet sniffer. I wish there was a way to turn that off, right? Like in Linux and containers, you can kind of cherry pick what functionality and what binaries are in that Linux container. So any SUID root binaries, you can just remove them from the container and reduce your attack surface.
You mean,
but on a Fortinet firewall, I can't go in and like pluck the binary that gives attackers the packet sniffer.
I mean,
because if I could, I would. I would just be like, I would just tell people, just remove that.
Historically, lots of problems with, we used to call network devices routers,
right,
and switches. Now they're all in one devices, but promiscuous logging for troubleshooting and network detection, network troubleshooting, really, that was a problem a long time ago. And it sounds like Fortinet was trying to address that in turning some of this stuff off. of course, in theory, in the old days, you wouldn't start with the logging turned on. You would just turn it on and forget to turn it off.
Right.
But I was also curious. I mean, a very thorough discussion of the issue, but I'm a little bit fuzzy on what if you ran a scanner, what the scanner isn't going to pick up, and what you have to find, sort of manually.
You mean as in you're threat hunting, or as in you're looking?
Well,
for
I mean, for
devices?
looking for whether your devices are vulnerable to this Fortibleed attack.
Yeah. So that's I scan a Fortinet device and it's running a version that, air quotes, is not vulnerable, right? It's running a newer version that is storing passwords more securely. Yeah. Right. So that's determined by version number, how it stores the passwords. Mm-hmm. Right. So version 7.211 is configured, is automatically your passwords are stored using a more secure hashing algorithm. 7.2.10 in previous was using an insecure password hashing algorithm. The caveat is, if I'm running the newer version and my password is still stored in the configuration backup as a SHA-256 hash, the insecure one, until such time I log in for the first time post upgrade, then it goes, oh, Paul was able to log in, cool, I'll just wipe out the old hash. And the reason for that is, if I upgraded to the new version and something went wrong, when I reverted, it still wanted to preserve those old hashes so I could log in and I wouldn't be locked out.
Right.
Yeah. Right. So one of the interesting things I read in the Hudson Rock article was that the way they found these was for sweeping the internet for exposed Fortinet management interfaces. How long have we been talking about don't expose your damn management interface to the freaking internet?
But I wanted to, Lee. I wanted to.
Oh, because it'd be easier,
it's a default
right?
on, and if I'm at home, I want to be able to telnet into my device. Because
telnet is really robust and lightweight.
I mean, it certainly helps CPU. Though, but this attack was sophisticated enough. Mm-hmm. Conceivably, it could have gotten my credentials without that.
Yeah.
And here's a couple of different ways that this particular campaign did that, Lee. And don't get me wrong. I don't think you should expose your firewall management interfaces to the internet. However, the cautionary tale here is, even if you did your due diligence and you're like, I'm not exposing that stuff to the internet. If one of your admins, for example, got malware that was an info stealer, they would collect your credentials to your Fortinet device. Also, however they could get into a Fortinet device, whether it was a remote code execution or through some other credential abuse of some kind, or they had your credentials or guessed your credentials, whatever, they put a password sniffer on it so that if you logged into another Fortinet device, they got the credentials for that one. And that's how they had so many credentials for so many Fortinet devices. Was, I don't want to say it was like a worm, but it was like an attack that it was collecting credentials and just kept using those credentials to collect more credentials. Even outside of attacking Fortinet firewalls, you got an info stealer on your Windows machine, and it's gonna collect credentials there, which is, I mean, it's smart, right? On an attack, from an attacker standpoint, super smart.
Yeah. I mean, they had 2.1 billion credentials they were trying against MS SQL, and 1.6 billion credentials they were trying against FortiGate targets. 320,000 attempted targets. This is, and if they got into like a third of them, if they got into like 75, it's more, about a quarter of them. Still crazy.
The other thing too, and this is the link that I put in there because it was super interesting. It was Kevin Beaumont's follow-up article on Fortibleed, which is, I think, even better than the original one. Just kind of goes over a lot of the, I don't want to downplay Kevin's writing, but Kevin was early on in writing about this. So, but that's basically all stuff I covered. In the newer one, he was like, some of this stuff doesn't make sense. And one of the things that doesn't make sense is one of the most used or prevalent credentials in the data set was a credential of like admin 3 and some password. I forget what it was. Like admin 3 doesn't exist as a user account on a default like Fortinet device. Your default username is admin. Your default password is going to vary. I think newer ones might actually make you set a password when you log in, but the username is still admin. So we're like, wait, what is admin 3? Well, that's a backdoor account that threat actors added after they compromised a bunch of Fortinet devices through a remote code execution vulnerability or any of the number of RCEs for Fortinet and put a backdoor on it. And so the attackers somehow discovered that credential, or they were the attackers that put it there and just started using that and found another like backdoor into the Fortinet devices, which is just crazy.
Yeah, just skimming the article you linked. Yeah, this is actually, this is somebody had time to take a breath and write.
Mm-hmm.
Like I said, no offense on the first article. I mean, you got to get the information out there, right? And the Hudson Rocks post quoted a lot of the numbers and information that he came out of that he wrote in that first article. So like I said, absolutely no beer truck running over Kevin on this one.
There's actually a lot more detail. There's even more details I didn't cover that Kevin talks about in here from helping customers. He also links to the Cloud SEK, had a great article on it as well that I read. That's where I picked up the little tidbit about their honeypot identification. So this is a pretty crazy campaign. Again, a lot of it's just like password stuff. It's credential abuse, most of it. I mean, some cracking in there too. Kevin seems to really make a point that, he says it right here. This is a side impact of the drunk Gen AI stupidity gripping organizations worldwide. Getting a 36 NVIDIA GPU cluster a few years ago would have required talking to providers, getting racks and lots of setup. Now, you get a Visa card, you rent by the hour, and log in a few minutes later. All your irreversible encrypted passwords aren't looking so hot in the age of on-demand compute at scale, where attackers who put things in open web directories can brute force large volumes of passwords at scale.
Mm-hmm.
So it's like, he says indicates some things in there that doesn't explicitly call out. What he's saying is these threat actors were not sophisticated enough, or their OPSEC wasn't up to par enough that they left their tradecraft open to the internet, which speaks to their level of sophistication. However, their attack was actually pretty well designed if you read through all the way they constructed this attack, right? He's also saying, like, today you can just go rent this stuff and put it on a credit card. Now, I'm not sure exactly how we could calculate.
He calls it out, Paul. He says degenerative AI craze has lowered the bar so far that Mr. Bean can crack passwords quickly using his mom's credit card.
Mm-hmm.
I mean, that's pretty much laying it right on the line that this was not sophisticated.
Right.
And it's actually something we as cybersecurity professionals will be paying attention to, is that, what adversary capabilities are out there for thanks to our AI work that's developed.
But he's also saying, and this is the reason why I linked to this one article on Fortibleed, because I think it has some of the best insights in even above and beyond this campaign. In Kevin's section that he levels some of my learnings from Fortibleed, he says organizations are constantly worrying about generative AI threats, but this incident has tens of thousands of organizations without even multi-factor authentication set up on boxes, providing VPNs still. There's a massive gap between what many cybersecurity people are talking about, frontier AI, and what's happening at the organizations they manage. And what Kevin's saying here is, and I don't want to put words in his mouth, but that our eyes not on the ball. We're focused on this Gen AI threat and Mythos and all this stuff. Meanwhile, you still have infrastructure deployed that has remotely exploitable vulnerabilities, weak password hashes, and lack of multi-factor authentication. One could turn to many standards such as PCI. It will probably tell you, Jeff, right, that those three things are things you should pay attention to.
Did somebody say PCI?
Oh dear God, the PCI.
You're exposing your management interfaces to the internet, end of life or vulnerabilities. Any one of those. No multi-factor. You're using weak password hashes. I mean, how many standards talk about which password hashes you should? And also, how much do we consider that SHA-256 was not as secure as we thought it was? Yes, we knew that, but I think this shined a spotlight on, yes, not only is it
it was secure until it wasn't.
Right. All you need is a credit card and 40 GPUs. And it's effectively meaningless.
Yeah, I had a conversation I was in a conversation the other day, and I had the wherewithal to ask about password strength. And I had a wherewithal to say, it's 2026. Why are we talking about reusable passwords and not multi-factor or other stronger?
Because multi-factor is a pain in the ass. And I finally figured out, since I'm onboarding to a new company, I finally figured out why they call it multi-factor authentication and not two-factor authentication. Because I've had to set it up like 42 times in the last 2 weeks.
Multiple times.
Right?
Holy shit.
That's
now
not enough.
I got to set up multi-factor authentication to set up the multi-factor authentication. And it's
I need to give Kevin a call. 42 is too low a number. No, seriously.
It's the product of 6 times 7, okay, Lee?
Yeah, I get it. But I don't mean to make light of Jeff's point, because it is a pain in the ass, but it's like in the corporate environment, we should really be talking about that. There are ways to make it easier, but if you don't send people there,
there's ways to make it easier. And soapbox moment. The fact that everything's tied to this, whether it's an SMS or whether it's an authentication app, you lose this, you're screwed. Or if you're in a certain small room in a house that you don't usually take this into because it's plugged in and charging, but you're trying to be productive, you can't be productive.
But so what you're saying, Jeff, is that you work on the crapper.
Something like that, yeah.
Yeah,
it's trying to be efficient.
That aside, though, Jeff, you've been this year, I think, harping on the fundamentals.
I have.
And I think this is a clear case where we've lost focus of the fundamentals. We've lost focus.
Or we never had the
right things to find as what's a fundamental
in the first place. Yeah.
Mm-hmm. Are we, the question is, are we using secure password hashing algorithms? Mm-hmm. Well, that would have really helped you in this case of Fortibleed, right? If you actually paid attention to that. And I think part of the problem, and Josh, this is something you and I have talked about, what are some great tools and methods for discovering how your passwords are being hashed, identifying those and helping you fix them? I think that's kind of a weak point.
Maybe not the best example, Paul, and I'll say it because of this. While I agree with you at one level, why aren't we talking about the ways to protect against your stored hashes being compromised? Because if whether it's weak or not is immaterial if the bad guy can't get to it. And how many different ways are there for a bad guy to gain access to? I mean, in the good old days, it was a world readable file that anybody could look at.
Right.
We got over that mostly, but there's still too many ways to gain access to the hashes, which make this a really interesting conversation. And let's get stronger hashes. But why aren't we saying don't put the hashes somewhere where bad guys can get to them? And what fundamental was being missed that's enabling that?
Yeah,
I think we should at least consider that as part of the conversation.
Yeah, I think, while in this case you can't necessarily patch your way out of it, we can't lose sight of the fact that keeping up to date with these firmware updates is huge, right?
Well, I mean, the thing that
doing that in incremental steps, because if I have already and this is a great example, if I had last year or the year before upgraded all my Fortinets to these versions, gone through the pain of having every admin log in, making sure the old hash wasn't being stored, now I'm in great shape. If I haven't done that, now I'm playing catch up, right?
Mm-hmm.
And that's you've accumulated too much technical debt. You need to chip away at your technical debt as you go and not let it build up until you're like, oh crap, all 5,000 of my Fortinet firewalls need an update because we're storing password hashes insecurely. Now you've got huge problems.
I was going to say something and now I forgot it. Dagnabbit.
Yeah, 2 questions for you guys. Do you remember the old C2 secure script? At least one of us. And 2,
never heard of it.
There was, in the HPUX universe, there was a time where when you moved the hashes out of Etsy password, it actually created a separate security file for each user in a very tightly secured directory tree. So it was like you had to walk a tree to find them all. It was a pain in the ass, and I was wondering, would that have been an improvement instead of all of them in one? And I'm thinking, well, would it take an extra 30 seconds for the hackers to find them?
Yeah, I mean that's obscurity through obscurity.
Yeah.
Well, there is some legitimacy to adding steps in complexity and layers. That one could easily have been scripted, and
Well, but and in HP's defense, they actually had other metadata in each file relative to the user's account and some permissions and some aging stuff. They were adding some password aging, rotation, and some other things into this when there wasn't a standard yet. So let's not throw HP under the bus. But you're right, Jeff. I agree with you. I just think once somebody figured it out.
Well, and you helped me to remember what I was going to say. I mean, the Fortibleed example with the hash being stored, just in case you have to back out and revert back to the older version. I mean, that's not a weakness as much as that's a design decision. That's a risk decision that's been made, and somebody, they may not have known this was possible, but in theory they would have considered this as a possibility. What if somebody gets to the older hash? But that's a somewhat legitimate risk decision to make. What would our conversation be if we were finding out, oh, Fortinet, if you change your password and you screw it up somehow, you're screwed, because they don't have a way to back up or revert back to the older version. That would be a bigger problem.
But I think we do this a lot. We're like, well, the barrier to entry is high. In other words, in order to crack these passwords, you need a 40 GPU cluster. So that's a barrier.
Right.
But as technology evolves, it's less and less of a barrier. And we're not even talking about quantum encryption. A lot of us are worried about quantum safe algorithms. This had nothing to do with that, right? It was just, I just need more GPUs accessible.
Mm-hmm.
Not a
That's
quantum
the question. Does hashing become a problem with quantum computing? I don't know the answer.
Oh, that's a good question. I'm not sure that
because hashing is not encryption.
Hashing is not encryption, but it's a mathematical transmutation of the characters that are in the clear text.
And I don't.
We used to just call that an algorithm, but I mean, I'm sure there's
people that know the answer to this.
I just don't happen to know the answer to it.
Wait, sorry. Ask the question again. I need to hear it. I'm sorry.
The quantum is making asymmetric public key cryptography vulnerable,
right?
Because it's a math formula, whereas symmetric encryption, which is just really, really big ass keys that you're still brute forcing. Now, hashing is a function, is an algorithm, and all the password cracking for millennia have been essentially brute forcing or guessing. Does quantum lend itself?
Yes,
lend itself to being able to do that more efficiently.
Sort of. Bear with me. You know what the ultimate answer to hashing is a rainbow table, right?
Yep.
Mm-hmm. So a quantum computer of sufficient power and size can create a rainbow table like that.
And just for giggles, define a rainbow table. Good ride.
Since a rainbow table, a hash given
It's
the
a
same
lookup
clear
table.
text.
Yeah.
Yes, effectively, a hash function given the same clear text always produces the same ciphertext, right?
Right.
Hash text, ciphertext,
and uniquely, and
unique,
well,
but the same. Given the same clear
all is
text
the
input,
same, but the idea is no two different inputs produce the same output. That would be a collision.
we're on the same page. I'm stating just something for the clarity here.
Okay.
So the same clear text produces the same ciphertext, right?
Yep.
With a hashing function. The concept of a quantum computer is that a classic binary computer does one thing at a time. A quantum computer does all of them at the same time.
Right.
So a rainbow table is effectively calculating a hash algorithm or hash system, a hash function.
Yep.
Thank you. And the rainbow table is pre-computing all of those hash functions with, let's say, every single letter, double letter, triple letter, quad letter, five pentaletter.
It's doing the brute forcing ahead of time and creating this big, massive lookup table, which means you don't have to do the math once you have a hash. You just look it up.
Right. Now,
I will defer this to security, cryptography, whatever. I'd love to hear their take on it because they're classically trained cryptographers that have an awesome show. What AI told me is that quantum computing doesn't make like SHA-256 as an example instantly breakable. It effectively halves their classical security level to 128 bit.
You were saying, Paul?
Thank you, Jeff.
Jeff is
Well played, Jeff.
very
That's
very
a
classically
we recognize-
trained.
not a cryptographer.
We recognize
And someone-
your Fort.
It's different.
We
It's
recognize
different.
your authority in Fort Kick-Ass. Not to worry, Jeff.
Yes.
Yeah, and classically trained, I might add.
Classically trained, meaning I know how to break the puzzles in the newspaper.
Not
What's
that the
in the
nuns hit
newspaper?
you with a ruler on your hand.
And then
much.
something about Grover's algorithm. Anyway,
What about Ernie?
I'll
and
defer
Bert?
that to the experts.
I thought it was Shore's algorithm.
in that, but it doesn't. In this context, right? It doesn't matter because you can go rent a 40 GPU cluster.
Vast
and crack
AI,
these
baby.
suckers. And that's, like the threat actors they care about results, and they're like, wait, I just need to have a credit card and 40 GPUs, and I can go crack these.
But to summarize what I'm trying to add to this is if hashes are susceptible to quantum-based attacks, why aren't we running around like the sky is falling trying to come up with quantum-resistant hashing algorithms the way we are?
I don't think we're running. So Fortinet's a great example. They did make an update to be like, yeah, you know what? We probably shouldn't be storing them in SHA-256. We should store them in something more secure, BBK DF2. And they made that update.
Mm. But I'm
I
sorry,
think you're-
I kind
I
of
think
got
you're-
distracted because Go ahead,
Dave.
Dave.
I think you're touching on something, kind of the last probably 5 minutes of discussion are revolving around a couple of different concepts. But there's something in the middle of that. So the first part is we're having troubles with fundamentals and basics, and
Trust Dave
that's
to be
been
in
a
the
thing
middle.
forever. It's like a sandwich. And then on the other end, we're also focusing on the really, really like bright, shiny objects of what is new. But we're not. So as defenders, we are focusing on the new thing, and we're kind of getting wrapped up in that and forgetting the fundamentals. The good part is, it sounds like some of the threat actors are too. The problem is there's a difference in the amount of effort necessary to do both of our jobs. And that is, I think, the thing that's really going to hurt us the most moving forward. It's at a magnification. It's even more easy for them to be more dangerous than it is for us to be more defensive.
Wait, say that again?
It's long story short. It is. Yeah, I'm just going to repeat the whole thing. No.
No, just the last
what I'm-
part. The
what
last part was good, Dave. I mean, it was all good, but the last part was the point you wanted to drive home.
It's the delta here of how easy it is to defend and how easy it is to be an attacker, it feels like it's getting larger because as defenders, we've got more things to pay attention to. We're getting excited about more things, and we're leaving the fundamentals behind even more so, it seems like, when theoretically we could be doing them better with AI.
I can show you the proof on that if you want. I can show you the proof on that. I just threw a link in chat. I actually we did a research report about a month ago at the nonprofit that I work at, or that I volunteer at, and for software supply chain security. So similar to what you're talking about, Dave, right? And it's incredibly bad. It used to be about 11 days for a vulnerability to be created as an exploit and to get out there and start being exploited, right? Now it's about between 11 and 30 minutes at most. So it's a lot harder for the defenders rather than the attackers. So valuechainrisk.org.
Think about what Dave is saying, because Dave, what you said was extremely awesome.
He normally is.
This is the problem. Dave hit on the problem that we have today, and I think it's one of the biggest problems we have today, is that we tend to chase the shiny new things and constantly refocus on the new stuff, the new attacks, whatever's new, and we lose focus on the fundamentals. However, and I'll extend what Dave said, if we focus on the fundamentals and do those really, really well, and don't lose focus on the shiny new things, but keep doing those fundamental things really well, when the shiny new thing comes out, because you've done those fundamentals really well, that shiny new thing is not going to be as much of a vulnerability, a threat, or an exposure.
I wholeheartedly agree. And then we all lose our jobs and nobody watches our show.
Yeah. Hey, if we just sat here and said you need to update your firmware which I mean we do say, but if that's the only thing, patch, and when you patch, you get new, better hashing algorithms. When it's the whole thing. Had you just tried and true, right? Had you stuck to the plan and not deviated from that to go focus on oh my God, there's a new thing, you would be able to defend those new things. You would we need to focus on building resiliency. And resiliency is not necessarily going to chase the latest and greatest thing and combat the latest threat. Resiliency is, how do I do things really well so that the next latest threat doesn't matter?
Or maybe it still matters
much.
Right. Yeah, it doesn't matter as much, or we have a lot more time.
You're reducing the impact. You're right, Larry. Absolutely.
Or we have a lot more time to detect and
I meet a lot of people at conferences. They're absolutely panicked that they're not using AI to the optimal within their defensive posture. But
unless you're using it smart, it doesn't matter.
Right. To be fair, there's a whole bunch of stuff that they're probably overlooking that are fundamental, that just like close the back doors, shut the windows, whatever it is you have to do those first, and you'll get potentially more bang for your buck.
Yeah, I mean, I guess unless you're running Cisco Catalyst SD-WAN. Good
nice
Lord.
Nice segue, Paul. Nice
segue. I don't want to pick on Cisco.
No, you do.
I'm not sure of the lineage or history behind
Why should today be any different?
Yeah, but I'm not sure about the history or lineage of the SD-WAN or SD-WAN manager products that they have.
They acquired
it probably acquired, right? But what would be a safe bet? What I can say, and so I ran this analysis through my vulnerability analysis tool. I ran this query based on some of the articles that I was reading, just to validate what they were saying, because a lot of people generate articles using AI. Go figure. And it hallucinates. Go figure. I using my tool, which I used AI to create, but in less than a year, there have been 7 vulnerabilities in the Cisco Catalyst SD-WAN family of products. 7 vulnerabilities added to the SysAkev. Tells me all of them are exploited in the wild, all 7. I couldn't really confirm 100%, but based on what I've read, I'm pretty certain all 7 were exploited as 0 days. So they were being exploited. Someone observed them. Bye, Lee. Thank you. As 0 days. And I'm just struggling to like come up with great defensive recommendations if you're using Cisco's SD-WAN products. Like, what do we tell you? I'd treat all your SD-WAN, Cisco SD-WAN stuff as already compromised. I don't know. That's a really bad recommendation, I think. But that's
is
the
it
best I got. Like,
but is it
that? But that's telling. I guess. Thank you, Larry. First of all, but that's the best I can come up with because, like, that is a staggering statistic.
But that statement implies that we know that implies you should take some sort of action.
Mm-hmm.
But we also know companies rarely take the actions we want them to take.
Yeah, what is that action?
So
Treat it
it's
as
okay that you
compromise. Like, what
it's
does that
okay
really
that you
mean?
made this statement.
But, like,
Don't feel
treat that as what is that? I mean, that could mean a lot of things. It's up for interpretation.
Yep.
But when you are treating it like it's compromised, what does that mean? Does it mean least privilege? Does it mean increased? There's a lot of actions, to your point, Jeff, right? You should take to treat something as, well, if it's already compromised, what do I need to do? There's a lot there. There's a lot there.
Can't do that. There is a lot there.
I mean, you could also just say the recommendation is throw it out and go get something else. Which I mean, in this case, maybe it's less work than trying to defend it. It's interesting.
How
from a cost perspective? 1 second, Dave. Right. From a cost perspective, am I going to spend more money trying to defend something than I will ripping it out and replacing it? Because there's a cost to both. And what if it's more economical for my business to go, you know what? I know we made this investment in Cisco SD-WAN, but you know what? Given where we're at now, we're better off just going with a completely different technology, and it's probably going to cost us less in the long run.
But what
I haven't done the study.
Yeah,
but
what does
I guess I'm like trying to motivate you folks out there that are listening. You should probably do that research because you may come to the conclusion that.
Well, I think a lot of companies
something else.
I think a lot of companies do go through that mental exercise to some degree, and what they often try to do, and I don't know if anybody can definitively say, okay, we've thought of everything, but there's all sorts of incidental costs associated with an upgrade. Like you've got some number of staff that are trained on the one product.
Oh no, I get it. Yeah. There's a lot of
you go on and on,
like
and on.
hidden costs,
compatibility issues.
Sure.
And
Dave was trying to pipe in there.
Let Dave have the floor.
Yeah. So, I mean, how long until the next SD-WAN product that they buy potentially gets compromised? That's potentially predictable.
Yes.
You look in history.
Sure.
So therein lies an argument, and I guess it's reasonable. I've noticed over the past, say, 10 years or so that it's become increasingly common for security leaders to just buy a security product and expect that they're going to need a backup of some kind. So they'll say, hey, I'm going to buy this thing, but I'm also going to keep something on hand in case this thing just stops working, effectively security double bagging it. What's the equivalent protocol for SD-WAN in this case?
I don't know, but also like 3 of those CVEs in SD-WAN are CVSS 10.0. Like they're breaking all new records. Like 7, I think I haven't done all the research, but I'm fairly confident that 7 CVEs on the Kev in less than a year in the same product could be a record. 3 of which
definitely the all-star team.
Definitely the all-star team. 3 of which are 10.0 on the CVSS
That might
scale.
be a record.
That might be a record. So, like, at what point do we really look at outliers? Like, this product is so vulnerable that it is surpassing all other levels of vulnerable for all other products, which means like the second product on my list, even if it had 2 CVSS 10s,
there's a military term
5 things.
for
Like
this.
maybe that's better. I don't know.
There's a military term for this, Paul. If you've watched Saving Private Ryan, FooBar.
Mm-hmm. Yeah. Yeah. At what point does
Is
it
it
cross the
beyond
FooBar?
all recognition?
Crosses FooBar on the scale.
Yeah.
And then I just can do something different.
They keep moving.
Does
the
this
bar,
segue
though.
into Article 17 now? Because like you're touching on recent history of just the magnitude of cybersecurity impact, and your Article 17 I think sums up really well.
Oh, that was one I didn't write up.
Or does everybody get a free pass now because AI is discovering so many more vulnerabilities? Everybody gets a pass. and we're just gonna
I don't know. I did have stories about AI finding vulnerabilities. Well, Squidbleed was one. It's a pretty amazing vulnerability in that it slipped past humans for 29 years, which I think is kind of interesting, right? Now, there's definitely some certain like select conditions that make this work. I was just kind of with my Squid proxy, I was kind of transported back to over 25 years ago or so, where we set up Squid proxies on free BSD boxes because we only had so many T1s that we had to cache the pages going out to the internet to save bandwidth.
Wow.
Which is apparently still one of the top use cases for Squid proxy. And I'm not, look, again, I have a rich history of Squid proxy. One of my coworkers at the time was all about it. And he was also big into free BSD. And he showed me what he built. And I was like, dude, that's actually really awesome. And he's like, yeah, by the way, I can monitor what websites people are going to. So I can tell if they're going to like a website that's going to get them hacked, or I can tell if they're doing something inappropriate in violation of our policy. Like, well, that's interesting because usually those sites also lead to them being compromised as well, and set up like a great system. And I'm like, dude, I think that's awesome. Like year 2000, he was like, I have FreeBSD running and all our web traffic is going through a Squid proxy. I'm like, that's pretty awesome. And I was it was more nostalgic for me than it was, but apparently people still use it for that, to cache that data to save bandwidth, which is not as much of a concern as it was, 26 years ago, but people still use it for that. And they had like it was like a heartbleed. Do they call it heartbleed like attack?
Mm-hmm. Yep.
It leaked memory. Yeah, it was like a heartbleed like attack that leaked contents of memory. And so I thought it was kind of cool that AI found this vulnerability. Anyway, that's Squidbleed. Larry, I wanted to go just something completely different. The Secret Life of Probe Request. Did you get a chance to read this? I know you were out today.
I did get a chance to read this afternoon.
So you can summarize it better than I can, and most certainly better than AI can.
Yeah, which story was this from viewers?
My story number 3.
Your story number 3. Yes. Yeah, so we've made some changes over the years about how our devices deal with preferred network lists. Back in the day,
this is the Karma attack. This is like one of our most famous, favorite attacks of all time.
Yeah,
dude, right?
Yeah. So Karma attack. Your device was out there probing for networks you've connected to in the past. Hey, I want to connect to Linksys. And if you're asking for Linksys, we can become Linksys.
I'm Linksys.
So,
right.
Yeah, I'm Linksys. Come connect to me. Rich and broad history of that, and lots of attacks. And it was, we saw that this was really, really harmful. So manufacturers have changed, and the Wi-Fi, setup has largely changed to try to prevent some of this type of stuff. But as a result, to change this to better improve, we've changed the way we do per requests for preferred network lists and so forth. It still happens out there. There's legacy devices out there. There are devices that, case in point, one of my Apple devices should not be probing for named networks anymore. But because it's been migrated and migrated and migrated and migrated onto multiple iterations of Intel hardware, that some of those networks are still being probed for by name. I don't know about moving it to an M series Mac, but in any case, there are still devices out there probing. And this one was actually kind of fascinating in that the author, Zachary Maitev, found that there were devices out there probing. And in fact, lots of devices out there probing, and probing for a very specific network known as default SSID. And there was another one that he noted. So why are all these devices out there probing for default SSID? Well, TLDR, these devices are out there probing for that SSID because that is the default SSID that they look for to perform their initial setup, to connect to Wi-Fi networks, to be to enable their IoT devices.
Default passwords boot us in the butt again. Jesus Christ!
Well, not so much
password,
default password. It's just
any
looking for a default network
piece of data. Come on.
It's basically a device going like, hey, is this SSID available? Because if so, I really want to connect to it.
Yeah, so so you can configure me.
Wait,
Please.
was it named free public Wi-Fi?
No, it's default SSID.
SSID.
I know, I'm
This
just
is what
kidding.
it was probing for. Like, and there's lots of different devices do this, even still today, right?
Yeah. So the fascinating part about this one is that the researcher Zachary went and was like, great, well, I can be default SSID. So he stood up, an open default SSID Wi-Fi access point, and the device refused to connect. Why? It expects a WPA2 pre-shared key network and not an open one. Okay. So what's the password? Well, using it is referred to as the Wi-Fi. Where is it here? Half handshake attack. You can set up an access point. You go through the 4-way handshake process. Step 1 from access point to client, client to access point, to exchange some nonces. You know the nonce. Once your nonce from the access point, once you receive it from the client, it is based on the pre-shared key. You can now take those nonces and that output generation, even though you don't have the full 4-way handshake, and effectively use stuff like Hashcat to recover the expected key for that network.
Wait, so you can intercept a nonce and derive the pre-shared key?
Well, you're not so much intercepting, is that you are becoming the legitimate access point.
Okay, yeah, I got you. You are the access point, so you're receiving the nonce, not intercepting it. You're because you're the SSID it's looking for.
Yep.
You're receiving the nonce. Once you receive that nonce, then you can derive the pre-shared key?
Correct. Because the math at that point for deriving the PMK, which is where the nonces come in,
right,
is based around some known math for the two nonces, one that you know because you're the access point, the one that has been provided to you by the
Just
client.
an FYI, I'm so turned on right now when you're describing this. It's so nerdy. It's so erotic.
Nice.
Do you guys want us to
I need a moment.
Yeah. Sometimes a cigar is just a cigar, Paul.
So awesome.
So you've got both of these components. You know how the math is constructed, and as a result, you can now brute force the pre-shared key into that function that was derived from those nonces, those unique numbers.
And so that's what he did here, right? He basically set up in access point AP mode, collect half the handshake as they put it, and was able to derive the key. And then what do you do once you have the key? I can become an access point that has that key, and it will fully authenticate to me, right?
Correct.
Yes.
And now you can observe all the traffic where it's going, and you can nmap scan it, and you can do all sorts of other fun stuff. And through that investigation, he was finding that the MAC addresses were to a specific set of wireless adapters from Mitsubishi. They were the Mitsubishi MAC 5771F, IF-2E Wi-Fi adapter, specific Wi-Fi chipset from Mitsubishi.
Yep. It says in my description they use in air conditioners, water heaters, and rice cookers.
Yep. I don't know about rice cookers, but he definitely noted that a little bit more on the industrial side. I mean, pseudo-industrial. So room air conditioners, refrigerators, heat pump, water heaters, bathroom drying, heating and ventilation, smart ventilation switches. induction cooktops and rice cookers.
Everything has Wi-Fi now.
Yeah, and this was the point. Like, you could go.
Everything
and
has an off switch to the Wi-Fi too. Just saying.
You could go buy a rice cooker and not ever care that it's connected to your Wi-Fi network, because you press a button and it cooks your rice, and then you're done. So these are those devices that are now in those modes, and then as a result, he found some scripts for some devices here that he could actually use some Python to change the values of temperature and interact directly with the device to potentially create some bad situations there.
Yeah. So Jeff, even what I think what Larry's saying is, even though you have this device and had no intention of configuring the Wi-Fi, because it's defaulting to go look for a specific Wi-Fi network, an attacker can capture that and take control of your device. Yep. So to your point, Jeff, but
it's still not on my network.
It's not on your network, but it's connected to an attacker's network.
And that so now that attacker now effectively has
controls that device. Can control that device.
I'm gonna lock my bag of rice up tonight then.
Well, you should also lock up your air conditioner and your heat pump.
But it begs a question.
Terrifying.
To Jeff's point, how do you turn off the Wi-Fi on these devices?
If the Wi-Fi is disabled, how's the attacker getting to it?
And I've always thought, because we're talking about TVs in a moment too, I've always thought I have a TV. If I just never associate that to my Wi-Fi network, I'm safe. But what this attack is highlighting is you need to turn it off, because if you don't configure it, potentially an attacker can configure it and talk to it on their own network, and then potentially interact with that device if they know what it's expecting or how the authentication works, or if there's vulnerabilities or whatever.
Right. And I Jeff, I kind of know where you're going like this. Well, one, how do you turn it off? Well, you probably have to configure the device to be able to get into the device to turn it off, which is kind of ridiculous. There's no button to turn it off. Likely. The other one, and not knowing which devices that these are being used and the types of environments, these devices could very well be connected via some other medium, such as, say, Ethernet, or Modbus. To other types of networks, which could then potentially be used for a pivot into a Modbus network to do other types of control, or potentially even pivot into other networks IP based once the access for Wi-Fi is
and I understand I'm somewhat of an anomaly, because I'm not what else can I control from my phone, and I'm automatically everything I buy plugging it into my Wi-Fi so I can see what's inside my refrigerator when the door's closed and stuff like that.
You're just weird, Jeff.
I am just weird.
Just get your ass up out of the damn chair and look in the damn fridge, man, for God's sakes.
But I'm not in the chair, Josh. I'm at the grocery store, and I forgot whether I needed to get cream cheese or not.
But this story makes me want...
Buy it again. You'll have 3 of them. No. You know what? You'll go through it.
You know what's frightening? This makes me want regulation that mandates that manufacturers put a switch that I can turn off connectivity. To Jeff's point, if I buy some kind of appliance and I don't want the smart functionality, I want a physical switch that I can go turn off all Wi-Fi, Bluetooth. And some devices have this, right? The privacy-minded devices, names escape me at the moment, right? I think this was a feature on some laptops too. Yep. There was a feature, right?
Dell, Lenovo, there was a physical
switch. There's a physical switch I can turn off Wi-Fi.
And do you know how many support calls that they got complaining
because people left it on and they couldn't connect? Yes.
Or didn't realize that they had switched to the actual physical switch and spent hours.
And that's probably why we don't see them on. It's exactly why we don't see them on devices today, because people. And I think you know what? I think I've been guilty of that. Why can't I connect to Wi-Fi? Well, I'm because I hit that stupid kill switch.
Yeah, but
now I want the kill switch.
Yeah, but also to your point, Paul, you think about some of these connected devices. Where do you put the kill switch on the device that it's easily accessible and not going to get bumped? Or now you have to have this kill switch, and it's a switch, and you have to redesign your cases, or you have to have some other consideration to the cases, which is now an additional expense to these devices
Right.
in many
It
cases
is
where
100%.
margins are already razor thin. Like,
Yep.
I
But if you're
Josh,
a
I don't know.
hardware hacker, like many of us, you're into hardware hacking. It's a lot of work to be able to go, what do I do to disable that chip and have the device still function? I don't know that I would go there on a lot of these devices. Like, that's dicey. Then the next thing that my brain goes to is, do I just put my whole house in a Faraday cage? But that's a huge expense and prone to leakage and all that stuff.
Copper cladded buildings are, they were a thing.
They exist, but it's big cost, right?
Yeah.
Mhm.
Yeah. I used to work in one.
But it was cheaper than providing the Tempest protection on each individual 50-pound monitor that you were using.
But it goes to my story number 7. Nearly half of the LG Smart TV apps contain residential proxy SDKs. And this is just a continuation of the ridiculous stuff that goes on with the devices as consumers that we buy and put in our homes. And this is just super shady. So Spur Intelligence Lab scanned over 6,000 apps. They specifically looked at LG's WebOS and Samsung's Tizen platforms. They found that just over 2,000 of them contained embedded residential proxy SDKs.
Okay, so what does that mean? Residential proxy SDK.
So they say these apps quietly route third-party internet traffic through your home TV and its IP address without most users ever. Well, you wouldn't notice this as a user. Says the apps involved are not the kind you would think to audit. They're screensavers, fish tanks, clocks, casual games, right? So they're basically poisoning somewhat like on the surface harmless apps, but under the covers, they have an SDK inside the app that gives other companies. Bright Data was one of the ones mentioned that is the most abusive of this. They are monetizing the TV's internet connection in the background. And as we know, this is the economics of it all. Samsung wants to make a TV. They want an app store on the TV. They want people to put apps on the TV. And Samsung, and I'm convinced this is how it happens. Samsung's going, hey, I can make your app like not uninstallable, or I can make your app prominent in our app store, and you give us some money, but you'll be able to make money on your app. So you're going to give us money to be in the store, and then you can do whatever you want with your app. We're not going to put restrictions on it. And the company's like, great, I'll make a screensaver that in the background, I can let Russia or China use this as a proxy network and charge money for it. So like everyone's making money. Sounds like I'm selling TVs. I'm getting kickback from the apps that are installed in my environment. I'm locking my users out of the visibility into these apps. I'm locking my users out into be able to uninstall them or monitor them or whatever. And the companies that make the apps are like, great, I'm making money because this is basically a proxy out of this person's internet access. The whole thing is shady. This is again a case where I would call for regulations and legislation to be like, this should never happen. We should not be in this situation at all.
I've got 2 questions, and specifically about this research. And the first one is more technical. And Josh, this is something that you and I deal with every day. So the research says that there are confirmed proxy SDK stuff in here. And now, is this just a function of the fact that the software components for the proxy SDK are included in the app, but and their analysis saying, oh yeah, hey, these can do proxy SDKs because the software exists in the binary. But are those particular functions that allow the proxy SDK functionality to happen actually active, or is this just left over because this stuff is used by an IP stack to go gather data from the internet, like they're saying that their EULAs are doing? So my question is one, is this really a threat? Like, are the components for the proxy stuff actually reachable by any of the software in use, or is it just present in the apps? And they don't really get into that in the article.
Yeah, I mean, they cite
No, they
other
don't.
instances of this from Krebs that talked about the Kim Wolf attack, which we talked about on the show. I don't think they've. I think they were just analyzing the apps, Larry. It's a
Yeah.
great question. Did they
Exactly.
actually observe this in the wild, or is it based on just reverse engineering the apps?
Yeah, it basically, I'm seeing here, like it's looking like they reverse engineered the apps, and how deep did they reverse engineer the apps?
Hmm.
Are the function calls there? Oh my God, danger! Are the function calls ever actually activated? Are they ever actually accessed as part of any of the program function?
I'm going to say yes. And the reason I'm saying yes is not because I have proof of it, but because the way that in the article, it shows you some of the consent screens that you can consent to do this, or you can decline and just watch the ads to play the game or things like that, right?
Mhm.
And it says, for example, play Pac-Man without ads. For an ad-free experience, please allow web indexing by Bright Data to use your device's free resources and IP address to download public web data from the internet.
Okay,
And I'm going to
see
tell you
one?
that sounds pretty much like they're saying either
Yep.
go ad supported, and that's cool because we'll make money off you anyway,
Either
or
pay
not,
us or let
and
someone
we need
else
to make
pay
money
us.
off you somehow.
Yep.
So
Yep.
I'm sorry,
and that's fair. That is absolutely fair.
that's not cool, man. That allows.
They also
traffic
said in the
into my
article,
network.
though, that Roku and other manufacturers don't allow this to happen. So rather than like overarching legislation, it's up to the individual companies that are making these devices to regulate whether or not they want apps like this in their store or not. And so what I believe the threat actors and or shady companies do is they go to LG or Samsung who are like, yeah, you can put an app like that in our store. But Roku and others are like, no, you can't have that in our store. And since, and again, it's economics. The TV from Samsung or LG is air quotes cheap, but the Roku device or whatever is like an add-on you have to buy after you buy your TV.
Mhm.
So the more money you pay up front, the more maybe a lockdown environment that you get. It's why I love NVIDIA Shield. And actually, I bought some Roku devices, and I find them to be better than some of the other offerings out there.
And so, Paul, I mean, you're a heavy user of some of these types of devices, and when you compared like those devices to the TV, my second question is, who actually installs this crap on their TV?
Yeah.
Like,
Dude, I'm going to say two words to you. Bonzi buddy.
But it's very similar to when we first got iPhones. We experimented with a lot of like flashlight apps, and because the app thing was kind of new. It's the same thing with these TVs and or entertainment devices. When they first came on the market, you explored the app store and you're like, oh, like cool, I can put like a fish screensaver. Like that's kind of, I did that like the very first week I got some of these devices 10 or 15 years ago. And very quickly I was like, well, all that is crap. Uninstall that stuff and have gotten new devices since then. Now,
Pac-Man. What buttons on the remote do you use to play Pac-Man?
I mean, NVIDIA has like a gaming platform on it, but other than that, I agree with you, Larry. Like you're not doing that now. I just want
joystick to play Pac-Man.
Oh,
they have NVIDIA has like a full NVIDIA
I
Shield
still
had a full
have
gaming controller,
scars and scabs from that.
right? But now I just want my entertainment apps, right? Like I want my streaming apps, and that's it. I don't want any other apps on my TV.
Yeah. I mean, I can get like, maybe the kids stumble across and they want to play Pac-Man and then they find out that it sucks and it's still installed there. But like, for the most part, it just feels like not many people are actually installing these types of apps on the TV because the experience probably sucks. And
Or they don't know how to do it.
Right.
Speaking for my generation.
Yep. Talking about my generation.
We were supposed to be dead by now.
Just remember, Jeff, don't trust anybody over 30.
Inches.
Including himself.
Including myself.
Jeff, did you had a couple of your stories were interesting?
I hope so. That's why I put them up there.
trying to think which ones I flagged. Foundational security practices. Your story number 4. Looming AI-fueled threats require urgent cybersecurity improvements, says the Five Eyes. You had a quote that said, executives should focus on risk assessment and air quotes, foundational security practices.
There's that pesky foundational fundamental conversation coming up again.
Mm-hmm.
And then my last story, 7 or 8, I forget what my number was. I actually found there.
7 was the actual statement of what they said. Right.
And I apologize. I don't know who these Five Eyes are, but it's from Australia, so it's got to be good.
UK, Canada, Australia,
New Zealand,
England, and US. Is that 5?
No, it's
New Zealand.
It's not
New
Zealand.
Zealand.
It's not US.
New Zealand, Australia, Canada, UK,
and the US. Yep.
Or Five Eyes. Yes.
Yeah, so it was a little bit of a Captain Obvious thing, but at least somebody's saying it out loud. And of course, we've been saying
what are the fundamentals?
Like, what are the fundamentals?
We just keep coming. Like, what are the fundamentals?
Guess what my next talk at some future conference is going to be?
We should talk. Yeah, it needs to. It's a conversation that has to be had because so many people are. I think, to your point, Jeff, are throwing around this terminology about security basics, security fundamentals. Like, what does that mean? And we've, I think, on this show, defined many different items that could fall under what security fundamentals are. Do we all agree on that or not?
I'll tell you we don't.
That's the question, right? And we don't. So what are the security fundamentals that we agree on? We almost need
and I think I said it last
standards
week.
and guidelines where we all try to get together and agree on what those should be in different verticals and different aspects. But
that's a good point that you make.
Liar. Get it? Liar.
Yes.
That's a good point, Paul. But let me throw this into perspective a little bit, at least. We can talk about IAM. We can talk about OT and IT and IoT. We can talk about lots of different
individual
things.
I don't think those are fundamentals, though.
But that's the point. Bear with me. The fundamentals are something I've been working with for a little while. They're attestational fundamentals. I can attest, and what I've been using is IEEE UL 2933. That's based on a clinical IoT standard, or it is a clinical IoT standard, and it goes for trust, identity, privacy, protection, safety, and security. TIPS is what they call it. So those are fundamentals. How, do you trust the system that you're working on, the people, the data, the technology, the process, the facilities, the AI, and how do you trust them? How do you manage their identities or manage the risk of the identities? And in every which way that works. And that's the kind of thing that we're talking about. And actually, and I'm not trying to be a jackass, but I built it. So if you want to go to valuechainrisk.org and click on Beacon Score at the top, you can grade anything you want for free. It's free.
Well, Josh, I agree with everything you're saying, but I think that's perhaps a second tier.
Okay,
I don't think you were on last week or whatever recent week where I was saying this.
Debate that. I'll be right back.
My idea of a fundamental of information or data security, maybe we throw in the cybersecurity term, is sort of deciding the goals and objectives, and what do you care about, what do you want to protect, what are you up against before you start talking about the technology. Now there are fundamentals of we've got technology involved, but I think there's a layer of fundamentals that sort of come before.
I mean, that's what I was just talking about, or am I misunderstanding?
Well,
like the trust, the identity,
I mean, you said a lot of the terms that, you were saying a lot of the things, but I thought you were wrapping it up in terms of applying it to systems, applying it to technology. If we're saying the same thing, that's fine. A few years ago, I was at once in a while, us old NSA information assurance people get together. And a couple of years ago, we had a gathering, and Chris Inglis, who was the first national cyber director, and he was some muckety-muck at NSA. I forget what his title was at NSA. Hi, Chris. Not that he listens, but he was giving a talk, and we talk about people, process, and technology. And he said the same thing, only he said it was people, doctrine, and technology. And I've been muddling that over in my head for years now.
Define doctrine in this case?
That's what I wanted. I mean, he's coming from a government
I mean, to
role,
me,
DoD
that smacks
role.
like process. You know what I'm saying? Doctrine, process, guiding principles, that kind of thing. So I think
But
process
there's something
covers that.
about culture too that I think seeps into this, right? Like you can have all these more technical definitions, but also there's like the higher level thing that defines your approach and almost like tolerance to risk and security at a very high level that I think plays into all of this, right? I've experienced that at a lot of different organizations, right? Like when I worked for university, there was not much. The guidance at the high level,
academic freedom. They didn't want any
exactly 100%, Jeff. Right? Like,
absolutely.
There was like we need to preserve academic freedom, and then I worked for cybersecurity companies, and we're like, well, our doctrine is like no one should have access to things they shouldn't. Like it's very, very locked down. And those are two opposite ends of the spectrum,
right?
But both are equally important to kind of define your, I don't know, tolerance or culture as it relates to security.
Yeah, I think culture is an important fundamental element to discover who you are, what you are as an organization, what business, what profession, what vertical you're in. I mean, in the early days of consulting 30 years ago coming out, when I was talking to companies about, if you're going to plug into the internet, you got to get secure. One of the common questions was, what's everybody else in, and I'm paraphrasing, in my vertical doing? I don't want to do any more or any less because I don't want to be blamed for not following best practices.
Yeah.
So one of the best practices
if I have
for
to
me,
do more than
a university,
I don't want to do more. Yeah, there was a huge thing in university. I don't want to do more than any of my peers, but I also don't want to do less than any of my peers.
Right.
But that's like a flawed model because like who's setting the standard?
Well, it's absolutely.
Right.
I mean, best practices, and in those days, nobody was doing anything, so you were good.
Best practice was to do nothing, right?
Right.
But shouldn't we always do more, just a little bit more than best practice?
I think so. But, I would counter that with, I would try to start a conversation on what's valuable, what are you trying to protect? And back then it was really, what's your CEO think or your board think about how much they want to invest in not being the next company named in, Wall Street Journal as a company being breached. And most always they're like, oh, we don't want that to happen. I'm like, great. Nobody wants that to happen. How much are you willing to invest in making sure that doesn't happen? And by the way, it could happen anyway. Really hard conversations to have. But I think more and more we need to have them. And I think our industry has been built around, that sounds really hard. You're going to make us think, and that's difficult. Just tell me what I need to do. Tell me what I...
Whoa.
Yeah,
tell me what box to check.
Tell me what box to buy. Tell me what silver bullet to buy.
Yeah, exactly. Yep. But look at all the history we have on this podcast and stuff we've talked about, all the nuanced things. Like, do those fall into some kind of policy, procedure, or cultural doctrine that we have? Like, we come up with all these new things all the time. And
yes, no,
one thing Jeff, I wanted your thoughts on, and I know you're gonna love this, right? Was the 2021 Honda Civic infotainment system can be jailbroken via USB.
Yep.
And I know, like, on the surface, that doesn't relate to what we're talking to, but it does, because someone or group of people made the decision, knowingly or unknowingly, that they would implement and roll out into production test keys,
right?
Like cryptographic. And I've seen this in UEFI and things in my day job. Oh, we're just going to sign in with test keys. Like, where does Paul, where does that fall in the doctrine?
Paul, do you have the story in your list? Yes, you do.
Yeah, it's my story number 10.
Because I think
right?
we had we may have talked about this story last week, or I
Maybe
had
last
it
week.
in last week.
Yeah.
Yes, the Evil Valet one. We did not talk about it last week. We had it in the list.
You had it in the list. Yeah, it's fine.
And this is also crazy Because
dude.
Because if we think about this, though, after they dug in and they noted that the stuff was signed with test keys, we think about how the security industry has evolved, and the implementation of the Android operating system on these vehicles in 2021 was designed and implemented in 2011.
Right.
So it was a 10-year lead time, which is not all that unusual in the automotive industry, especially in 2021. That, hey,
I was going to say not unusual in the evolution of cybersecurity either.
In 2011, we weren't really thinking about that as much as we were nowadays.
Yeah,
so
but
we should have been.
But this is my encryption's only as good as the key and how you protect it, right?
Yep.
Like, Jeff, this really speaks to so many conversations we've had on air and off air about specifically encryption, right? And the encryption's great.
Well, and to recap, encryption algorithms are hardly ever broken. It's always the implementation, especially key distribution and key management.
Dude, like I heard you say that when I read this article. I was hearing you in my ear,
right?
In all the conversations we've had over cigars, and on the podcast, the whole thing. I'm like, oh my god, this is the shining example of. Encryption's great. It's just many people, as we know,
many
so many really super smart people developed the algorithm. They test it. We run through multiple iterations. Like, look at all the algorithms we talked about a couple of weeks ago that are trying to be deemed as quantum safe, and all the things they go through. But so, most of them are hinged on, can you protect the private key?
Mm-hmm.
And in this case,
well, if it's a public key algorithm,
right?
Can you protect the key?
The private key was not private; it was a test key that multiple people had access to, and therefore, all integrity and privacy is out the window. That's how easily it's just not a security control anymore.
And I think in an analogy which more people can understand if they don't have this, if they're hung up on the crypto thing, web forums, web applications, you have fields to fill out. The early days of e-commerce where you have to type in, let's say a credit card number, which is 16 digits.
Mm-hmm.
Why would anybody, or you're just filling out your address with a zip code of 5 digits. Why would anybody put 10,000 digits into a field that's only looking for 5 digits?
Because I can.
Because I can. And it can be exploited to break things. Yeah. I mean, it's that type of mentality or lack of mentality. It's who would possibly use this for anything other than what
we
it was
assume
intended?
Because it's encryption and there's a key that no one else.
I can't read it, so therefore it must be.
Yeah, it must be. But this, and I've dealt with this numerous times in UEFI and all the other things. More than one person had access to the key, or the key leaked, and it's public knowledge.
Right.
That's often the downfall. It's not the algorithm. It's not the attacker. In our previous example, you started the news segment, right? Someone has access to a 40 GPU cluster that can, cryptographically break or use rainbow tables to break it, right? It's not that.
I wish I had one of these 40 years ago.
It's like you used a key that other people had the knowledge of that key.
Mm-hmm.
And there's so many times in history in the past 30 years where that's happened. And we haven't learned.
Right.
Oh, it's frustrating. We haven't learned those fundamentals about security, privacy, and encryption that get us here.
Surprise, surprise.
Right?
And what did you pre-select the title for this segment to be? Because I feel like a title's coming here to
it's a great question. We can have a discuss. We can change it.
Mm-hmm.
I said so cloud visibility, which is our sponsored segment, right? Fortibleed, which we talked about a lot,
A lot.
Hacking things the easy way, I think, covers
Yeah,
that covers
works.
it. It does.
that works.
That can almost be the encompassing title for this whole show: hacking things the easy way. Specifically, what was I referencing in that? Probably most of our articles, right?
Sure.
Yes.
I mean, at least the ones we've talked about.
100%. Oh, but I was also referencing domain takeovers, and this happened to be a TP-Link example, but this exists in. There's been so many. We've covered articles on this on the show, and this is a huge thing in cybersecurity, right? Where you find a in this case a firmware or a system that uses a domain name to in whatever capacity, right, inside the product, and they like forget that they registered that domain name and they let it lapse. And either a security researcher or an attacker takes over that domain name because it's lapsed and it's baked into a product, and they're able to collect information about it. Shining example, I think, is malware tech Marcus Hutchins, right? Was like, oh, that domain name is available. I'll just register it and see what happens. And it happened to be what was his big thing?
It was effectively the neuter, the shut off of what one of the big.
Now I can't remember. WannaCry. It was WannaCry. Yeah. Because Marcus has done great work, well above and beyond that, right? But that was a great.
He's also done great work well and below that, too, which he acknowledges.
He's amazing, awesome person. Much respect, right? But there's so many occurrences of this. This is just the most recent one, right? Like TP-Link. Someone leaked like a TP-Link thing where someone could download all the firmware for all TP-Link devices. They specifically analyzed it for all the domains they were using, and they're like, "Hey, there's this one domain, and like I registered it." And all of a sudden, there's this TP-Link devices that are communicating with this domain, allowing me to do stuff. And by the way, that person reported it to TP-Link. It was like, hey, I got this domain. By the way, your devices are reporting to it. And TP-Link is like, yeah, that's an issue. And he's like, can I just transfer this domain back to you so you can fix it? And they're like, yeah. And he did that. And that's the way it should be, right? Like that's awesome. So I just want to call that out on the show. This person did the right thing. TP-Link did the right thing. Like TP-Link made a mistake, but I'm not faulting TP-Link in this case because there are so many things we need to keep track of. And if we lose track of one domain, that could be an exposure, and that happens. So,
the one that kind of bugs me a little bit about this whole thing is, I get the initial disclosure, and the initial disclosure here it bugged me a little bit when I think we talked about it. It was from Simone Margiatelli.
Yeah, I recognize that researcher's name. Yep.
Evil Socket.
Evil Socket. Yeah, that's Evil Socket. You're right.
I found an unrestricted S3 bucket where I can list all the versions of firmware for the devices. And guess what? They have them listed all on their website.
Sure.
All the versions. And you can just click on stuff on their website. This just made it easier. Like that I don't know so much that was a vulnerability. But as a result, it gets called out. It just made it easier so that now researchers could take larger quantities of firmware for analysis such as this.
But that's also a double-edged sword. Like, I am glad that a researcher who got access to that analyzed the firmware, found something, reported it responsibly, and then like the end result was transfer the domain so we can make the world a more secure place. But if a threat, I kind of get both sides of this, right? Like if a threat actor gained access to that, they may not go through responsible disclosure. And I get that.
Yeah. Now, the other one that I think, and I'm trying to read through the article because I remember seeing it in here before. I think kind of the intent here was around the long line, domain collision attack. And this may have been one that they never intended to have registered, because it was being announced via MDNS on the local network.
Mhm.
Like we use the .local MDNS stuff for that now, but
Right.
can we do other TLDs via MDNS? Yeah, absolutely we can. And maybe this was only ever intended to be on the local network for MDNS, and so many IoT manufacturers. Oh, this was Fritzbox back in the day.
Yep.
With the .box top level domain, which then later that became an actual thing, the .box TLD.
Right.
So if it was only local MDNS, I get it.
Oh, you're bringing me back, man.
I'm not gonna register that. It's only local stuff. But what happens when now MDNS isn't supported on your network? It's not working.
It became it wasn't a top level domain previously, but it is now.
Yeah.
Which afforded the opportunity for an attacker to register the domain.
Yeah. I mean, I can understand the potential developers' reasoning why they never registered it.
No, agreed. But there's so many times when the attack is as simple as, oh, I just need to go register a domain because someone lapsed on that. And that happens.
Yeah. I mean, these are all things that I've exploited over the years.
Yeah, 100%. We've in the past 20 years, we've so many examples where the attack was as simple as, oh, I just need to go register that domain.
Yeah, or
and
email
then I get
address.
all the things.
Yeah, case in point. I've talked about this eons ago as part of a presentation. Josh Wright, as part of one of his classes many, many years ago, made this fake clown dating site as part of a CTF challenge.
Yeah,
and he one of the email addresses, I think, for the fake administrator of this fake dating app was damnclowns@gmail.com. And he hadn't registered it, so I did.
Oh no!
And I never told anyone about it. Never. I told
not
Josh,
even a domain, just a Gmail address,
just a Gmail account. No, and no periods, no nothing. I told nobody about it. I never used it anywhere. I just sat on it and listened, waiting for it to happen. And sure enough, 5 years later, it starts getting email.
Are you serious?
Serious. Because some dude in North Platte, South Dakota, thought it was his email address. And I don't know whether he misspelled damn with a D-A-M and everybody else actually put D-A-M-N spelled correctly.
Right.
But I started getting his PlayStation account emails, and the ability to do password resets for PlayStation, and his bank, and his he apparently worked for a very large company where I would receive notifications that he had received and could sell his monthly stock options.
Oh my God!
And had access. So I understand how these things happen, and we've abused them for a really long time. I still have that email address, by the way.
You seriously?
I love you never gave it up.
Yep. The only problem is that I haven't logged into it in a really long time.
Oh, they might have recycled it. Yeah, Gmail did a huge recycling.
Yep.
Not that long ago. Yep.
Yeah. And I haven't logged into it in a long time. They probably did a recycle, and I think I lost the password to it in some system move and couldn't actually log back in. So
I think many of us have lost more emails and access than we may have.
Oh, I have
pretty close.
I've done workarounds for so many domains, it's not even funny.
Yep.
So yeah, absolutely.
Well, with that, we're a little over time. Thanks everyone for listening and watching this edition of Paul's Security Weekly. Larry, take us out.
Over and out.